This is a video on how to work problems calculating for work and power. Let's look at this first problem. How much work does the lift do if it applies a force of 2,300 newtons to lift a car 40 meters up out of a lake? Well, let's first look at our formula that we have. Work equals force times distance. Let's see what we have. We have our force is 2,300 newtons. Our distance is 40 meters. So let's plug it into our formula. Force is 2,300 newtons times 40 meters. So work is equal, after you multiply them, to 92,000 newtons times meters. Or a nicer way to put newtons times meters is joules. So 92,000 joules is your answer for this one. Let's do another one. Solving for work. How much work does the lift do if it applies a force of 500,000 newtons to lift a tow truck 2,000 meters across the road? Let's start with our formula first. Work equals force times distance. Let's see what we have. We have our force, which is 500,000 newtons. Can't forget your units. And our distance is 2,000 meters. So let's plug it into our formula. Force is 500,000 newtons times 2,000 meters. When you multiply those together, you get this really big number of 1 billion. And for our units, it would be newtons times meters, but we can simplify that and just write joules, J for joules. Let's look at another example. How much work does the lift do if it applies a force of 23 newtons to lift a desk 5 meters across the room? Let's start with our formula again. Work is equal to force times distance. Let's see what we have. Our force is 23 newtons. Our distance is 5 meters. So let's plug in what we know. We have 23 newtons times 5 meters. And that is equal to 115 newtons times meters. Or simplified version, 115 joules. Now let's switch gears and see how in the world we calculate for power. If the engine from a car can do 14,500 joules of work in 17 minutes, or 1,020 seconds, how much power does the engine produce? Well, now we have a new formula working for power. Power is equal to work divided by time. Work divided by time. So we have work, which our work is in joules, 14,500 joules is our work. Now our time, give you a little pointer, because power, its units are always in joules divided by seconds. So we're going to use the seconds. So 1,020 seconds is our time. So let's plug these numbers in. we have 14,500 joules divided by 1,020 seconds is what we do to solve for power. And after we divide that, we get 14.215. And this is joules per second. Now let's simplify both and round to the nearest tenth. Tenth is this spot. So we're going to look back and see this is a 1, it's less than a 5, so it's going to stay the same. So our number is going to be 14.2, and we're going to simplify our units. Joules divided by seconds is also the same as watts. Or you can just put a capital W. Let's look at another example of power. If a beaver can do 52 joules of work in 3 minutes, or 180 seconds, how much power does the beaver produce? Well, let's start with our formula first. Power. To find power, you're going to do work divided by time. Let's see what we get. Our work is 52 joules. Our time, we're going to do in seconds because that's our units for power, joules divided by seconds. We're going to do 180 seconds. So let's plug in our numbers. 52 joules divided by 180 seconds. And that is going to be equal to 17.333 repeating. And these units are joules divided by seconds. But we got to simplify both. We're going to round to the nearest tenths place. So it's going to be 17.3. And we're going to simplify this by saying W, or watts. Let's do one more example. All right. If an elephant can do 1,500 joules of work in 10 minutes, or 600 seconds, how much power does the engine produce? Let's start with our formula. Power is equal to watt work over time. Not watts, work. Watts are our units. Okay. Our work is 1,500 joules. Our time from this problem is 600 seconds. Let's plug in our numbers. Our work is 1,500 joules over 600 seconds. And when we divided all that, we get 2.5 joules per second. We have to simplify. Our number's already simplified, so we just bring that down. 2.5, but this is going to be in watts.